Hi, good morning, good afternoon, good evening, wherever you are in this beautiful world. This is a series of webinars from IEEE. This time we are trying to put some light on AI, specifically in autonomous vehicles applications. Who am I? I'm an industry veteran. I did work at BMW for about 33 years. And since about 10 years, I'm standing on my own and doing all kinds of consultant work. Here in this case, we are working to, I'm supported by my program committee, you can see on the right side. And we are trying to moderate interesting issues in the industry in front of normation, respective standardization. IEEE people will, of course, look for the need of standardization in the background, but here the first issue is to bring light to, so to say, hot potatoes, what is going on in the industry. Some housekeeping issues. Everybody is aware that this is going to be recorded and it will be later on available as an on-demand video. Please keep your microphones muted as long as you are not speaking. And in case there are any difficulties, please communicate to the people in the background via the chat feature. Most important, please, this is more lively the more questions are coming. So please use the Q&A button. It's a pleasure for every speaker to feel the interest to answer any questions. Please feel free and use it. So what are we going to do? Trustworthy AI for autonomous vehicles. I'm quite sure AI, everybody is aware of, used in all kinds of applications, apps, face recognition, and whatever. But what is going to happen if an autonomous driven car without driver controlled by AI is going to come up in my mirror on the German Autobahn with whatever kind of speed? Safety critical applications? We don't have yet, as far as I know. But I'm sure, on the other hand, I just joined the AEK, the International Automotive Electronics Conference, the last 2 days in Ludwigsburg, and clear AI in automotive applications will come. So we will see what has to be done. We got 3 speakers here today, Daniela Rittmeyer, John Nass, Riccardo Mariani, and hopefully in 1.5 hours, you will be much more enlightened. The first speaker, Daniela Rittmeyer, she is since 18 years in the industry. She studied at the MRIT Melbourne. I'm a little jealous. I would have loved to be in Melbourne as well, in conjunction with the Bauhaus University in Weimar. Then she joined the VSP group. I really don't know what VSWSP group is. Looks like an engineering service company. I do know Daniela from her job at BMW, where she promoted AI. And now, specifically, she only since some weeks or months, she joined Capgemini. Capgemini, one of the biggest consultancy firms in the world with 350,000 people. And she is there responsible as head of AI automotive in Capgemini. I think this is definitely a global job. Okay, Daniela, what is the relevance of artificial intelligence in automotive? Are these hopes really, is it fair to say, yes, it will come? Your turn.
Thank you, Axel, for the nice introduction and the invitation. I feel really, really honored to be here today in your IEEE webinar and to give you some insights about my experience concerning artificial intelligence, the relevance of automotive and trustworthy AI. As you said before, I will give an overview, or as we aligned, concerning that topic about relevance of trustworthy AI in automotive. And today I will not go into detail of the technical aspects for autonomous driving, because I guess Ricardo from NVIDIA and also John from EuroCAD will do that. But before we start with automotive, let's start with a recent example of trustworthiness. Perhaps some of you have heard last week the announcement of Microsoft. They stopped selling their emotional reading technology. So what does that mean? And what does it also mean for automotive? Because of disadvantages, they limit their face recognition. And the disadvantages are not based on technological limits. The background are legal and ethical limits. So what can we learn from that recent example, and what does that mean for automotive? So while we are developing AI technologies, we have to put the human into the center and take also ethical and legal limits into account. Artificial intelligence is a key technology of the 21st century, and data-driven developments are crucial. So before we start the deep dive into automotive, let's have a look to the global AI world and what is happening at the moment. At first, I would like to start with the technology. China is investing and driving the AI first strategy since 2017 and 2018. And also the United States are in the middle of the, I call it, war for technology, and pushing R&D investments forward next to the development of the tech giants and the active startup system they already have. And also the EU has upgraded their investment up to $5 billion until or for the next years in artificial intelligence. Let's go to the value side of the story. What we can see at the moment is an increasing industrialization along the entire value chain. As one example, you can see or can feel and experience the scaling of the large language models as GPT-3. And what else can we see concerning data value? A decrease of affordable costs concerning artificial intelligence and an increase of the performance of machine learning. When we put our focus to partner and partner ecosystem, I would like to point out that 5 of the hyperscalers are in top 10 of the market capitalization. And concerning partnering is also interesting to see kind of triple boost of merge and acquisitions from 2020 to 2021. And at the same time, also the investments in startup doubled. We will see what will happen concerning in the current inflation and the current development with the startup. That would be very, very exciting within the last months and years. And if we come to the human side of AI, we can also see in the last years that we get plus 50% of publications around trustworthiness. We see a rise of AI ethics with plus 25 legislations. And I guess that also leads us to the webinar we are here in today and the topic we're in today. So another interesting point, if you look around the world, is that the humans and their workforce are expected to be reskilled. I would like to point out a future of job report from the World Economic Forum, where they indicated that 55% of the workers have to be reskilled until 2025. And they expect that more than 100 million new jobs on data and AI will come up. So if you look around the world, you see artificial intelligence is driving the industry and driving the information. From my perspective, I always say you need a solid AI strategy, not as nice to have, not as must have. I see it like a kind of surviving strategy for your corporate. Let's go to the next aspect and to the question, but what's in for automotive? Why it is so interesting for the automotive industry. And I would like to point out that 3 areas. The one is from the customer perspective. The automotive industry is expecting 10 times revenue because of data-driven developments. The data-driven developments are the core for sustainable and connected products. And they are also the baseline for new business models in the context of future of mobility. If we come to profitability and efficiency, we can see an average cost reduction of up to 19% in the core processes. If you're focusing on the maximization of automation, especially of the repetitive routine tasks we have in the automotive industry along the entire value chain. And last but not least, everything is about speed, 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 and acceleration. With the help of machine learning, you can have a continuous improvement of your product development. And you will get a real-time feedback along the entire value chain. No matter if we are talking about the feedback from the customers, from the vehicles which are on the road and in the ecosystem, or in the each or other area from the processes. So if you would like to be successful, you have to master the tech challenges to ensure the sustainable leadership position in future of automotive. The question is also where and which part of the OEM value chain the Trustworthy AI is relevant. Axel already mentioned that I started my AI journey 5 years ago in the BMW Group in the center of autonomous driving. And of course, for each and everybody, autonomous driving with simulation, tests, validation seems to be obvious that you have aspects around Trustworthy AI. If we talk about safety, technical robustness, accountability, and ethical aspects. But I will not go into detail because the other speakers will do that in the next short sessions then. But let us have a look to the other use cases where Trustworthy AI is relevant in the OEM value chain. I would like just to pick out some of the use cases or some of the areas. At first, let's have a look to supply chain. We are looking forward to get a sustainable, connected, end-to-end supply chain system, like we are developing Catena X in Europe, for example. And their transparency is a key and really relevant for the applied AI use cases. If we go to manufacturing, we see at the moment a lot of quality control platforms coming up in the automotive industry. And there, especially for the employees, privacy and data governance is a crucial point. And if we look to the future of sales and marketing and think about the future of metaverse and conversational AI, it is about society and environmental well-being. And also in the, let me say, support functions and the automation of that support function, like, for example, human resources or recruiting, trustworthiness will be a crucial point if you think about diversity, non-discrimination, discrimination, and fairness. So as conclusion, you can say Trustworthy AI is and will be more and more relevant along the entire value chain of the OEM. And if you like to be successful with the AI integration, you have to take also the legal and ethical aspects into account. So now I would like to give you a short overview about the development of the legal and ethical regulation in the EU in the last years. Everything started, and I guess all of you know, the high-level expert group, which set the base in 2019 with the ethic guidelines for Trustworthy AI. And what have they identified as the most important thing for Trustworthy AI? It should be lawful, ethical, and robust. And they also derive the 7 key requirements for AI systems. I will not go into detail because we just have had that before, but in the focus on the mind of the automotive industry, the 3 important things are technical robustness and safety, diversity, non-discrimination and fairness, and also accountability. Based on that guidelines, Capgemini and also a lot of other corporates defined their own code of ethics. We did that in 2019, on the one side, based on the high-level expert group guidelines, and on the other side, based on our core values and business ethics. So I think that's really important that the different corporates think also about that, what impact that has on their business ethics and their core values in their corporate. So from our side, we focus on AI with carefully delimited impact, sustainable AI, which will be, from my perspective, a focus topic in the next years, fair AI, transparent and explainable AI, the controllability of AI with clear accountability, and the robust and safe AI. And last but not least, that we use AI respectful of privacy and data protection. If you would like to learn more about what we set up and how we set up and handle that with clients, you can just follow the link or the barcode and read out the one or the other paper from our research institute. How did the journey in the EU continue? In 2021, the EU Commission published the EU AI Act, so the definition of guidelines and regulations for AI applications. From my side, I think that it was a really positive development if you look to the first steps and also the AI white paper, which was published in 2020. And why it was a positive development? Because they said not they will look on artificial intelligence as technology, as holistic approach. They said they will just look into the direction of the use cases. And they will not also look to all the use cases. They focus on a risk-based approach, just the high and unacceptable risks. So that means we don't have that whole bunch of technology regulation. It is limited and focused. And what are the four most important things of the EU AI Act? The aim is to ensure AI systems which are safe and respects existing laws on fundamental rights and EU values. The second point is to ensure legal certainty to facilitate AI investment and innovation. And the other point is to enhance the governance and effective enforcement of existing law on fundamental rights and safety requirements. And last but not least, to facilitate the development of a single market for lawful, safe, and trustworthy AI applications and prevent market fragmentations. As need for action, I see the three most important points, like the missing definition of an AI system. There is no clear definition so far. And especially for the automotive industry, it's really, really important to harmonize the legislation and the regulation. Because in automotive, we already have a lot of regulations, and sometimes we can also say it's overregulated, and we have to align these EU AI Act, for example, with the motor vehicle type approval or with the type approval for the 2 and 3 vehicle systems, and also with ISO 26262. And another point I would also like to mention here, because this is really, really important for the automotive industry and how they develop and bring the cars to the road, is a clarification concerning partnership and the handling of third-party responsibilities surround the EU AI Act. So we assume that the regulation will come end of this year or latest next year, and we see a need for action, not only on the EU and legal side, we also see that on the corporate side. So if you haven't done so far, it is our recommendation to establish an ownership and a strong internal processes in your corporate. Please set up and approve your corporate code of ethics or code of conduct. Identify the relevant, especially high-risk use cases, and enhance the transparency in your corporate and qualify the relevant stakeholders while you're developing AI applications. It's also important to derive the measures to drive the technological robustness in your corporate and to establish corporate structures with AI advisory. If you need some help, just contact me or one of our AI or ethic COEs, so the Center of Excellence around the world. So thank you for your attention from my side. I hope I could give you a small overview about the relevance of trustworthy AI in automotive. And I think it's time for Q&A. And I would like to close the short impulse with the quote of Alan Kay, who said, "The best way to invent or to predict the future is to invent it." Thank you for your attention.
Thank you very much. That was really a pleasure to listen to you. And just now my telephone did ring. This is a live seminar, so please have fun. And there are questions. Some people even I know, Matthias Lippmann, ex-BMW, he's still working with BMW. So Daniela, good question. If we should trust AI, then we should have also engineers doing that job. Matthias is asking how many proven capable AI engineers are existing today, worldwide, Germany, or whatever figure you have. And of course, how many are going to come? What are the universities doing?
That is a quite interesting question. And to be honest, I cannot give you a transparent answer because I'm not into details so much. But what I can say is that there are too less. We can see the war of talent around the world, and everybody is fighting for the best talents to educate them and bring them in the corporates. And it is also what I learned out of my last 5-year experience. It is always a question, what is an AI engineer and what is not an AI engineer? I would like to point out, to bring successful use cases, AI use case and applications to the road, you don't only need AI experts, you need an interdisciplinary team with the AI expertise, with data scientists, and what is really, really important, with a good mixture and a good team also with the business experts who know their processes, who know their business, and they have to work together, and these combinations bring success and value to the road. I hope I answered the question.
Let's see, of course. Thanks, Amy Heidner, real-time feedback. Yeah, it's also, at least the question is clear, going into privacy. If my style of driving goes into whatever kind of learning, do I want that or not? How will drivers or owners know that the AI feedback system is not spying on them? I think that goes to your issue. You mentioned the keyword transparency.
I have to read. Real-time feedback is also lodged for the privacy. It depends on how you, yeah, okay, how will drivers and owners know? How to answer that question? It depends on how you structure that, yes? How you anonymize the AI application so that you cannot identify the individual at the end. So there are several techniques and technological options to avoid that you don't have that privacy issue. But we have to work on that in all that application which is going into the direction of privacy and real-time feedback with customer data.
The next one I love, Luca Di Mauro. In your opinion, in which measures or by what is missing really to align the EU AI strategy with United States and China? Obviously, there are regional differences to be looked for. You referred quite a lot to what the EU is doing, but maybe you can enlighten us a little bit more what is going on in China, respectively United States.
Yes, so what I can also say out of my experience from autonomous driving the last years is that the regulation is different around the world. The EU is handling it like we mentioned before, and they have the EU AI Act and have a lot of discussions and participation. In the US, the regulation is running totally differently. It's more on, how to say that, on self-certification, and the whole regulation process is different. And for China, again, it is also different. And what we saw and what China announced, that they will do also a kind of regulation which is leaning on the EU regulation and the EU AI Act, but they would like to put something on the top. But I haven't read anything yet, and I haven't read any draft about that. I just heard and read the news about that. But
that's a very interesting
from an automotive perspective, and the challenge, perhaps I can answer to that, the most automotive corporates around the world not only try to sell that features and functions in Europe or in Germany, they are global and like to sell that and apply that all over the world. And that is a challenge because you have different regulations all over the world and you have to handle that.
Yeah, and this is obviously one of our core values here. We are trying to keep the world together. This is also from my personal background. I worked in China for quite some time as well. So this is one of the issues really we would love to keep the world together and to avoid that China or whoever is going to fall out of the worldwide context. Another question, kindly can I have the screen mark at the left? Oh, sorry, that I can't answer. John Sub, in some AI methods, the underlying features are developed by the machine itself and inherently hidden from the use. In such conditions, how do you provide transparency? Yeah, this is a key question. Of course, it comes back and back again and again to transparency.
That's a good question. I think you cannot answer that. You cannot answer that on a holistic approach. You have to go into the use case and see how you can handle that. And I think there is no final solution yet. That's why also the EU AI Act is in discussion and in participation to develop that further on. And you have to have a look to that use case and the different methodologies which you use for that use case, and have to solve it in there and ask that questions there. I think you cannot give a holistic answer to that.
Okay. Unfortunately, fortunately, we have so many questions, but we have to cut time. So nevertheless, I would like to pose the last one from Mr. Karchenko. He is saying, thank you very much. There are many documents, guidelines, papers describing AI quality characteristics considering domain-related issues. We have calculated more than 70 such characteristics. What is your opinion, Daniela? How systemizing and these characteristics, it goes along the questions, is there any chance for KPIs? I learned something yesterday as well about that. What is your view?
Should I read it again? There are many documents.
The question is how to make it calculable, how to make the reaction of the machine transparent according to, can you put some KPIs on how reliable the recognition must be, for example?
Yeah, you can do that, but you cannot do that on a holistic approach either. So we have to see what the use cases are and what are the relevant characteristics you would like to measure. And yeah, cannot answer that.
Okay, we will see. I learned a lot yesterday from a Qualcomm presentation during this conference, and they really try, they do have a set of KPIs, and they believe that it can be put into clear figures so that we can all trust the things. But this will be an answer hopefully going to be given in our October workshop. We are going to have a workshop about AI in the automotive field in October of this year. So thank you very much, everyone. I have to cut for time needs. We have to go to the next presentation. Thank you very much, Daniela. It was a pleasure. Keep well and see you next time.
See you. Thank you.
So we are going to have the next speaker. The next speaker is going to be John Maas. He is a telecommunication industry engineer, an MBA. He served for 10 years at the European Space Agency in Norway, Netherlands. He worked on Envisat and METO projects, 2 Earth observation satellites for environmental purposes. In 2000, he joined the engineering company Nuevas Tecnologías Especiales. I'm sure that must be a Spanish company. And since 2008, he joined Eurocat. Eurocat is a company to support technology development in Spain, in Barcelona. He is going to speak about the increase of trust in CCAM systems. And Johan, what means CCAM? Your turn.
Okay, thank you very much. And thank you, of course, to inviting me to this webinar on behalf of IEEE Standards Association. It's a pleasure to be with you all. So good morning, everyone. Again, yes, my name is Joan Mas. I am the director of this Digital Technologies Division at Eurecat, and you were explaining a little bit what was Eurecat. Let me just give a few words in addition, because indeed Eurecat is much less known than Capgemini and NVIDIA. So I would just like to give some hints for the audience. So Eurecat is a research and technology organization. We are based in Catalonia. Actually, our headquarters is in Barcelona. I'm speaking from Barcelona right now in Spain. We are about 700 people, 700 professionals, 20% of them holding a PhD degree. And what does Eurecat? Eurecat brings technology-based innovation to companies, to businesses, to public administrations as well, in the field of manufacturing industry, sustainability, biotech, and digital. And this is why we are also involved in issues like autonomous vehicles and the like. So you were asking what CCAM is. I will explain in a few minutes what a CCAM is, but I will advance that it stands for Connected, Cooperative, and Automated Mobility. So I will just give some context about the overall speech. I will talk about the challenges that we were trying to face in when we say, what does it mean to bring trust to the CCAM? I will just use a few minutes to talk about explainability as an enabler to get trustworthy autonomous mobile systems. Also, I will focus a little bit more on cybersecurity, how cybersecurity is relevant to have trustworthy CCAM. And I will talk a little bit about a project named Selfie, whose objective is precisely this, to bring cybersecurity in order to make viable the CCAM. I will go a little bit into the detail. And then finally, some conclusions about what do we have to do for getting this industrial implementation of all those matters. So the context. CCAM, I already said that CCAM stands for Connected, Cooperative, and Automated Mobility. Actually, CCAM is a kind of partnership built at European level with 3 main objectives. So first of all is to create a more user-centered and inclusive mobility system, increasing road safety while reducing congestion and environmental footprint. That is one of the first objectives of this partnership. Also to boost collaborative research, testing and demonstration, because this is a pillar to really bring CCAM into reality. And then working together at European level to remove barriers. You know that in Europe we have many nations, many countries, many laws, legislation, plus the European Union. So try to find a unified vision at European level is one of the objectives of CCAM. Actually, CCAM is an association which gathers in the order of more than 180 stakeholders that can be car manufacturers, OEM, tier 1, tier 2. It encompasses as well transport authorities, road operators, connectivity and telecom providers, mobility and logistics services, and indeed academia and research centers like ours, which really try to boost the research and development side of the CCAM. So in short, the CCAM tries to bring viable intelligent transport systems in the era of autonomous and connected mobility. So the challenge is to have these systems, these autonomous mobility systems, reliable and basically ensuring trust so that all the stakeholders, including final users, can really rely when those systems become a reality. So it's a very important step forward to get CCAM, intelligent transport systems in the autonomous context, viable. So one of the main considerations in connected autonomous mobility is to ensure, as I said, this trustworthy system. To do that, we look at some guidelines, a little bit similar to what Daniel explained before, some guidelines that apply in Europe, and particularly we looked at this Trustworthy and Autonomous Vehicle Policy Report by the Joint Research Council in Europe. And this report stands some principles which are basically based on ethical concepts, ethical grounds, like respect for human autonomy, prevention, fairness, or explainability, and indeed some requirements at technical level in order to get this trustworthy artificial intelligence, which is in the core of those systems. And of course, the idea today is not to go into the detail of all of them, but I will focus a little bit on the second one, technical robustness and safety. So for what concerns these ethical principles and explainability, so in the context of autonomous vehicle, explainability is connected to the transparency of automatic driving systems. The software models and algorithms that compose those systems must take explainable decisions to the stakeholders involved in the system. If we're limited to black box algorithms, we need to implement additional measures like traceability, auditability, or transparent communications on system capabilities and the limitations. And for what concerns technical robustness and safety, systems must be designed to be reliable in front of risk. They have to minimize the likelihood of unexpected harm, especially harm due to unacceptable risks and harm towards humans, the users, and the environment as well, which is an important issue here. So one important element that we have to take into account to strengthen this robustness and safety is to put cybersecurity in the loop. Cybersecurity is an important issue when we are talking about data interconnection and interoperability and sharing of data. This is a very important aspect to take into account. So a few words on explainability, because explainability, as we said, is an enabler to trustworthy systems, mobile systems. So here you can see a chart which depicts the findings on the word explainability along the years. We see that before 2016, there was almost nothing on the network. As we go from 2016 up until today, we see that the word explainability is much more present and it's becoming an important fact when we are talking about artificial intelligence systems. So explainability applies to different level of or cases. Scientific understanding. So the human goal is to gain knowledge. We do not have a complete way of stating what knowledge is. So the best that we can do is ask for explanations we can convert into knowledge. Or for instance, when we go to the ethical ground, the humans might want to guard against certain kind of discriminations, and their notion of fairness might be too abstract to be completely encoded into the system. So, for instance, how do we know that a classifier system for loan approval is fair? So we need to go and deploy technologies and techniques to allow to explain these kind of decisions that systems, machines are taking on our behalf. So Here, this chart, and my purpose or my idea is not to go into the detail, but the idea is just to summarize in this chart the taxonomy of the different techniques and algorithms and software-related operations that may help us to explain the artificial intelligence decisions. And just focusing in some of them, some of those that could be interesting in the environment or in the context of autonomous vehicle, we would like to highlight these techniques based on black box model post hoc, which are very useful when, for instance, we are talking about deep learning for identifying images. Deep learning and applied to computer vision is one basic technique that we encounter in autonomous vehicle, and explaining decisions out of the algorithms that we are implementing are very important, are crucial to for the reliability of our system. Here we have, and I put in the screen some other models. As I said, I'm not going to go into the detail, but I just leave it there. And if audience is interested, they can go further finding about those elements. And we spoke about explainability. Now let's focus on cybersecurity. And to do that, and cybersecurity in the context of the projects, in the context of autonomous vehicle and an autonomous vehicle systems, I would like to explain a project that we are now developing in EURECAT. But just to give a little bit of context, it's a fact that cooperative and connected automated mobility ecosystems will become a reality in the coming years, because connectivity and digitalization and the use of big data and artificial intelligence is, putting all together this possibility. But this also gives rise to the possibility of new kind of cyber attack surfaces and vectors, which are becoming or will become apparent and will become the challenges on this system. And the fact that this is a reality and is something that really makes a worry to the reliability of those systems. This is why we are proposing the project Selfie, which I will explain in the coming minutes. So Selfie is a European project. Probably I need to make a clarification or an explanation for this audience that is not of European origin. And when we talk about the European project, we refer a project that is funded by a European Union, by this Horizon Europe program, which is putting a lot of money, a lot of resources in place to develop research and innovation around different subjects. This particular project actually is a 6 million funded project. It is a project that is carried out by 16 players, and EURECAT, we are leading this project. And the strategic vision of Selfie is to become the main European provider of an agnostic toolbox, agnostic meaning independent of car manufacturers and so on, for the self-management of security and resilience of this CAM ecosystem, which can be easily deployed over the environment, providing self-healing tools. Basically, the main objective of Selfie is based on three main tools that you can see summarized in this slide. A first tool that talks about the analysis of the situational awareness and processes that take into account in the CAM. The second performs resilient improvement actions, the second tool. And this tool, we call it the Cooperative Resilience and Healing System. And the third tool, which refers to guaranteeing data security and privacy when data are shared. Just to understand a little bit and to give an overview of Selfie, Selfie will be a whole bunch of software, a whole bunch of software applications that will be deployed at three levels. First of all, the first level will be at the level of cars. And here, one of the main objectives of Selfie is that this software can be independent or can be agnostic about the mark, about the manufacturer. So we want this system to be, let's put it this way, at least universal at European level. So Selfie will be deployed at the level of the car. It will be deployed as well at the level of the road infrastructure. You can see here road infrastructure. So all the elements in the road, antennas, etc., will also be provided with this kind of software. And also it will be deployed in the cloud, so that sometimes data from cars will go to the cloud through servers which will be owned by the different manufacturers. And below we can see some of the use cases or situations where Selfie may act. For instance, controlling or assessing security regarding people in the road, the vulnerable road users. And VRU stands for vulnerable road users. Or we can use it in the frame of collaborative self-resilience activities in front of hazards, cyber attacks, or other type of hazards like, accidents in the road or things like that. And then there will be as well the possibility to perform a self-audit and a self-healing functionality, which will be ongoing constantly, and it will allow to react when we find a problem, for instance, in a certain vehicle. We identify some wrong parameters or some situations that tell us that this vehicle, for instance, is not in a good shape. Then it will be possible, for instance, to put this vehicle in this safe degraded mode. So it's a very ambitious project. We have started, but we believe that providing all those tools will really exemplify the possibility of bringing in life these autonomous systems. The Selfie relies on four main pillars. One pillar of trust, which is trust completely related to the user, helping so that the user really accepts and is confident about the type of solution that Selfie is providing. It relies on the situational awareness, so it's crucial to have all the information provided by a number of sensors, cameras, etc., which are providing the real life situation of the conduction of the vehicle, for instance, in that case. It also relies on resilience. Concept of resilience in that case is focused on the required actions that will be taken for produce a self-assessment of the different CAM systems, and then the protection and the privacy of this data sharing that, as we've seen, for instance, in some questions of previous in the previous session, are very important in order to preserve the privacy and the proper use of those data in the context of the project. I have to say that the Selfie will be tested in three different scenarios. Actually, first of all, indeed, we will have a proof at lab level, but the project will be tested in three different scenarios, which are those one. The first one will be a test in the resilient and cooperative mechanism, precisely to identify and see that it works properly in front of vulnerable road users, and to preserve the safety of this particular type of people involved in mobility. The second one, the second scenario will be to secure empowerment for the backend system for traffic management system. So the backend of Selfie will be somehow tested in order to see if it is resilient, if it withstands stress situations. And the third case is a real mobility scenario where we will be testing the robustness of Selfie applied to a platooning mobility type of a scenario. And in this particular case, and according and to explain what you are seeing in the view graph, the project will deploy the 4 pillars that I was mentioning before: trust, situational awareness, resilience, and data sharing in 2 levels. The first level will be the deployment through the different architectural elements that make up this CAM system, so vehicle, the telecom and infrastructure and road infrastructure levels, which are very important at the level of cloud and indeed at the level of user, final and end user. And the second type of deployment of the project will be according to the different systems that we have in the project. And in that case, selfie tools will be implemented, for instance, within the different software algorithms that make up the solution, in communication protocols or in secure architectures across the project. And finally, just few words to see how this can be feasible in an industrial framework, so that the implementation can be feasible. So the first recommendation is to consider cybersecurity, resilience, and transparency as design. So we have to take cybersecurity and all these other elements, as I mentioned, explainability, transparency, etc., from design. So meaning from the start point of the project, we have to consider those things in the equation. Then the second kind of consideration is that the whole system needs to be taken into account. We have to look at the whole thing, not only the vehicle, because, well, sometimes we try to really focus on the vehicle systems because we want to have this vehicle, achieving very fast level 5 of autonomy. That's very important, and we have to do that, but we do not have to lose the overall system approach. This is very important. Third item is facilitate the release of guidelines for the industry with the aim of following the standard requirements, and this is appropriate for the purpose of this webinar. And the final one, but probably not the least one, is tied to put means for testing and verification as the use cases that we want to implement in the selfie project. And with this, I conclude my presentation. Thank you very much for your attention.
Thank you very much, John. Really interesting what all is going on in this field. Just a question, you mentioned it's a EU project. Are you aware of anything similar going on in other regions? If you want to implement, for example, a software on car level or on the OEM service and so on, of course, everybody would like to have something, a standardized worldwide solution and not to do
yes,
specific European solution.
Okay. Yes, actually, one of the members of this consortium, of this European consortium, is precisely the Royal Melbourne Institute of Technology, the place where Daniela was studying. So we have them on board, and that gives as well the possibility, to enlarge the geographical impact of this project to other areas than in Europe. I really don't know if there is a similar or something equivalent going on at the European or at American or other places, other regions in the world. But as you know, one of the requirements that we have to implement when executing European projects is dissemination. Dissemination is one of the most important elements that the European Commission wants us to do while we perform a project. And I'm sure that there will be a number of opportunities to explain the evolution and the results, particularly of this project, to many wide type of audiences.
Okay. Another question. I'm a classic automotive engineer, and I learned to hate black boxes. This was really,
Yes.
the automotive industry loves white boxes. We want to understand what is going in the box. Obviously, in AI, this is not really possible. You mentioned some, some starting points, at least, what to do to put more transparency on black boxes issues. Could you explain the starting point, the strategy behind a little more?
Okay. I think that, every use case probably will require a specific approach to identify explainability on the results given by our algorithms. But okay, one potential strategy is to try to connect as much as possible all the inputs that we obtain with the inputs that we are feeding into the system. Probably, it is, as I said, it's something that needs to be considered on a case by case. Probably in some applications, in some cases, this approach may be feasible because we are playing with a relatively small number of parameters. In some other cases, we will have to find different approaches. But to be honest, to answer this question, I should have here the real engineers that are dealing with those things in the day-to-day basis, the day-to-day.
Last but not least, do you have any timing on your project? When should this software, for example, be downloaded in the vehicle, be available?
Yes. Okay, this project was started to be somehow designed and conceived already 1 year ago, but the project itself started a couple of months ago. So we are in the beginning of the project, and it will be a 3-year-long project. You know that the timings of the decision timing by the European Commission is rather long. So since the time when we presented the project until the time when we got the green light, I guess that maybe 8 or 9 months have lapsed. So that's it's a pity, because it's time that you are losing or you are not, taking advantage of. But yes, at least some intermediate results in 1.5 years, final results in 3 years.
Okay. Okay, last technical question, and then a question I'm sure you will love. Terry Branch is asking, how is it ensured that the self-audit, which you mentioned to be put in the vehicle in a safe mode, is functional and not cause an unsafe condition instead of a safe condition?
Okay.
So how to avoid that the machine is doing the safety functionality is doing something wrong? Huh?
Yes. Somehow, who is controlling the controller? Somehow, this is the type of question, right? Okay. Indeed, this is a risk that we might encounter, and indeed, is something that at the design phase we have to take into account, and we have to really increase all the tests that we will do in the lab context, so that any harm or anything can be unleashed because of this potential problem. But yes, I will answer Terry in some months' time. But in any case, we will take into account this remark to have them in our testing plans of the project.
Okay, and the last, I'm sure you will laugh, Saba, okay, I can't pronounce that name. Euricat has a cloud platform with the necessary storage architecture. Who are responsible for the data management? Are these, sorry, that wasn't, someone wanted to study at your and follow your Euricat approach.
Yes, okay. I didn't mention. Sorry, So we are leading the project, but in the project we have 15 or 16 members, and we particularly at Eurecat, we do not provide the cloud facilities for this, and but indeed someone else in the project is taking care of how this implementation from an architecture point of view needs to be developed. We are more focused on the development of the algorithmic part of the project. And yes, this work will be open. All the papers that will be produced by the project will be open. Actually, this is mandatory by the European Union. All the results and everything will be open. But it's true that in the context of European projects, the companies that are participating in these projects, they might have some rights about the use of the results, because some of the we are a non-profit organization. I didn't say that at the beginning, but some of the companies or partners that we have in the consortium, they are for-profit companies, and therefore they want to keep some rights about using the results and exploit them commercially.
Thank you. Sorry, I have to cut the question session here now. No question is going to be lost. We will transfer all the questions to the workshop in October for sure. And one question comes up again and again. Is there anything going to be available for download in form of PDF or whatsoever? Yes, there is an on-demand video available to watch the presentations again. Okay, thank you very much, John. It was a pleasure. Let's go to the next.
Thank you.
So next is Riccardo Mariani, and he is really one of the widely recognized experts in functional safety. He worked many years at Intel as a chief functional safety technologist, and is really deeply involved in many IEEE activities as well. So, Riccardo, enlighten us how AI and safety bring autonomous machines to life. Obviously, without safety, it doesn't work. The stage is yours, and we are changing here now a little bit from the platform side, so I hope this is going well, the ladies in the background. Yes, it works. I can see your presentation. Riccardo, stage is yours.
Okay. Hello everybody. Many thanks, Axel, for the introduction and for the invitation to this webinar that is very interesting. I learned a lot of things. So in the next few minutes, I want to describe a bit more how AI and safety and in general trustworthiness are relevant in the context of autonomous vehicles. I will also show some example in video with the purpose to demonstrate how this works in reality. And by the way, I also take the opportunity to mention that in the IEEE magazine, Computer magazine, in fact, we will have issues exactly on this argument in November. So now I want to start with a video that introduces the importance and impact of AI.
I am a visionary, expanding our understanding of the smallest particles, and the infinite possibilities of the universe. I am a guardian, protecting us on all of our journeys, and ensuring ensuring our most precious passengers make it home safely. I am a healer, searching for hidden threats in every cell. In delivering precise care with every breath. I am a helper, taking on complex tasks in the most challenging environments and giving our crops room to grow. I am a creator, transforming the very fabric of our everyday lives and using the creative DNA of the masters to inspire a new generation of art. I am a learner, taking just minutes to discover how to crawl, walk, and stand on my own. I am a storyteller, giving emotion to words. Und die Sprachbarrieren abzubauen. I am even the composer of the music. I am AI, brought to life by NVIDIA, deep learning, and brilliant minds everywhere.
Okay, so the idea of the video is in fact to demonstrate the many use cases that are using today AI. And so if you also look to the complexity of the AI model, it's incredible. It has increased so many X time in 5 years, 30,000x in 5 years. And now it expected that is doubling mainly every 2 months. So you have already seen a lot of example. And so if you look to the journey of AI, it started to doing games, and now it's really at the center of autonomous vehicles. So, I mean, if we look to the autonomous vehicles, it's not just the cars, but it's everything that it will be autonomous and will have AI. So, and this is our mission to develop self-driving technologies that enable all of those use cases. This is what we call technology NVIDIA Drive. So it extends to not just car and robotaxis, but it goes in trucks, in delivery van, in buses, and agricultural vehicles. So also what is important is not just us, it's hundreds of many companies around the world that they are working with us on that project, including tier one, supplier, so company working on software. As I mentioned, the companies for robotaxi, who is doing map, the supplier of sensor, and so forth. So also what is important, and I think has been already said by the other speaker, is that AI is both outside and inside the vehicle. Inside the vehicle, it's used to do the autonomous driving, but also it's also the task is to give a cockpit that is smart. And this is where AI and extended reality, they combine all together. But so if we look about the role of AI in autonomous machine and vehicle, as you can see, there are a lot of roles. For sure, AI is used to understand and perceive the environment, but it's also used for reasoning to calculate the trajectory. It is used to do the actual maneuver, as also used for the mapping and HD map. So it's a lot of tasks. So, but I want to focus in one of them that I of course is one of the most famous, is perception. So our stack on perception is built on state-of-art ML models, and we have those models for all sensors, including camera, radar, LiDAR, ultrasonic, as you can see from the videos. And by the way, all of those, they run at the same time in autonomous vehicles. This is also explained why it's very important and complex to manage all of that all together. In order to build then an AV stack and a great user experience, you don't need just to handle the things like obvious, like detecting object, but also you need to detect signs, you need to detect traffic lights, lanes, road boundaries, intersection, and so forth. But also we need to understand other aspects, like the gesture that the people may giving to us, and also who is inside the vehicle. So it's a complexity of the use cases. So I want to show another video with one example.
Welcome back to Drive Labs. Today, we'll be talking about Parking Sign Assist, or PSA, which identifies parking signs and intersections relevant to the road. It also decides whether the vehicle can park on a current road using only live perception. Here we see our live perception PSA stably detecting the parking start sign while going under an overpass. The system detects the sign, classifies the sign type, triangulates its 3D position, and creates a new parking strip. As the Eagle car drives on the road, the system is able to understand how it moves in and out of the strip. It then closes the entire strip when a matching parking end sign is found. In this clip, PSA classifies that the European no stopping sign applies only to the right lane. It identifies the Eagle cars in the strip, so it cannot park or stop on the right curb. It also detects an upcoming bus stop sign on the left lane applying to oncoming traffic, and triangulates its 3D position to create a new parking strip on the left. Finally, PSA interprets the intersection as an M parking sign and closes both parking strips based on local rules and regulations. And here we see PSA interpreting a no parking sign that applies to the right strip. As soon as the Eagle car passes the current right strip, the system changes from car not in strip to car in strip, as indicated by the visualizer. The system then determines that the no parking sign still applies until it reaches an intersection. So we can only park after passing that intersection. By using live perception, WaitNet and SignNet DNNs help PSA decide three things: whether the Eagle car is in a parking strip, what the restrictions are, and whether the Eagle car is allowed to stop or park within that region. Restrictions are decided by national and local rules, which can be loaded in the system area by area. If you want to see more videos, please check out our previous episode of Drive Labs.
Okay, so again, you have seen an example. What I want also to talk a little bit is how AI can deliver a completely new driver experience. So using our Drive AX as example, AI is fused with extended reality to give a very intelligent experience, mainly in three key domains: sensing, assistance, and UX. On sensing, you have features like the visual landmark, the visual state, the sensing activities to understand the state of the driver, and also sensing different attributes and also who is in the car. Then the AI assistant gives functions such recognition for speech recognition, the gesture recognition, and also give view and the model of the cabin. And all of that is fused for AR visualization and multimodal AI. But so, how this is done? So how do we develop and deploy AI, and how we make it safe and trustworthy? So first, what is very important, then you need to have a framework in order to develop and deploy AI-based system at scale. And this, on one hand, it consists in data center in which you manage data and you train model and you couple with vehicle that they collect data and there you test the AI stack. Then in order to run all of that at scale, then the computing environment has to have all the storage and the power and the data management as well to develop and also train the models. And then the system in the vehicle has to be easily updated over the air in a safe and reliable way. But so, I mean, it's a lot of very nice things. It seems easy, but it's not. The problem, as you know, is very complex. It's a matter of the amount of data. It's a huge amount of data that they need to be, let's say, used, encoded, and stored. Then the data, they need to be analyzed in order to find the usual amount of frames. Then all this data, they need to be searched for maybe edge cases and situations that can be used for the training of the model and optimization. And all of that has to be done efficiently in the sense that you cannot wait years. So how you do that? And this is also a key point. I think it was mentioned earlier on that one of the key aspects is verification and validation. So what you really need is a completely end-to-end infrastructure in which you collect the data, you train the model, and you do a lot of verification and simulation. And then you upload all of that into your hardware, in which you need redundancies, and that is the architecture. So what I want to invest a bit of time, because it's key to guarantee safety and trustworthiness, is the aspect in simulation. So in our architecture, in the Drive Constellation and Drive Sim, is an open, bit accurate, is based on the cloud, real-time, hardware-in-the-loop simulation infrastructure with which you develop and validate the AV at scale. So it's capable to simulate a wide range of scenario and condition. It starts from routine, so driving, to rare and dangerous environment, the edge cases. And also, this is very important because in this way, you can identify what we call unknown unknowns. And so if you mine in that kind of a situation, then you can do a rigorous amount of tests without also investing huge amount of time in the road. So that is really allowing a greater efficiency, a cost effectiveness, and safety. So in summary about that, in order that you trust AI, you really need an end-to-end validation approach and strategy, in which you start from the bottom with the simulation of the SoC level, with hardware in the loop, up to the system and algorithm verification. And of course, at the end, you also need to do road verification and testing. So now I want to show another video that demonstrates the benefit of doing such kind of a simulation, and in particular, the importance of generating a multiple of scenario to cover edge situation, edge cases. Okay, so in fact, you have seen the importance of creating random scenarios, and that you can do just in simulation. So very quickly, the drive sim architecture is mainly composed by a virtual reality environment and a computer, and that kind of a simulator using many models such as the environment, the traffic, the vehicle, the sensor, and scenarios. So now I want to switch gear at the end of my talk is to discuss about more in detail about dependability and trustworthiness. So I think we have already understood from the other speaker, you need a combination of aspects. So you need to have availability, you need to have resiliency, you need to have reliability, you need to, of course, have functional safety and security and time determinism. All of that is what you need to achieve. So we don't have the time to go so much in detail, but one of the questions that I also have seen in the chat is that how many, let's say, reference exist, how many documentation and standard exist. So as you can see, it's a lot of them. And from all the different organizations, of course, from the IEEE, from ISO, from IC, and other also like UL. So it's really a forest of standardization activities ongoing, and they cover all aspects of the AI, let's say, framework. So the organization, how you develop AI, how you design AI, the functionalities, the implementation, the companies. So what I want to focus on is where I am directly involved, that is about functional safety and AI. So one of the standards that is ongoing is the ISO IC TR 5469, and is a foundational report on functional safety and AI system. We are at the DTR so level, and we expect to publish this one by end of this year. It's a lot of stuff inside it, is organized in chapters and annexes. One of the things that is very, I would say, unique at the moment is that include a classification scheme in which the AI technologies are divided in 3 classes from class 1 to class 3 and different usage level. So if the AI technology is directly involved in the driving scenarios, or if it is just a checker, all those kind of usage level, if it is used online or offline as a tool. The combination of the classes and the usage level define a set of requirements that you need to address in order to mitigate your risk. The TR5469 also define a model in layer in which the different elements of AI technologies are identified. This is very important since I have seen that very often AI is seen as a kind of a blob, as a magic box, but in reality, it's composed by a set of technology. A portion of them, they can be analyzed using existing standardization activities like the ISO 262. For example, the library of the DNN operands or also CUDA, you can certainly analyze with existing functional safety standard. Other elements like, for example, the machine element, so the framework or application graph, indeed they require a new standardization approach, and this is where standards like this are helping. The TR5469 also include a list of many different let's say, aspect that you need to analyze. We already discussed some of them with the other speaker, like explainability and so forth. It also gives a set of techniques for verification and validation, including using the doing verification in simulation with data, a set of techniques for the with which you can do a checking of AI redundancy, AI diversity. It also includes example for robotics and automotive. The other one that I want to mention is the ISO Pass 8800, that is the safety and AI in the context of road vehicles. I'm also quite involved in that. We took inspiration, of course, out of the TR5469, but we focus on the road vehicles. And he also aligned very strictly with both the ISO 262 and the ISO 21448 SOTIF. It's also under development, and we expect to have it by end of the next year. Then we have the ISO TS5083, that is somehow safety for ADS, for the automated system. It includes an annex, the Annex B, about AI, in which ML is analyzed, somehow is based on the ISO Pass 8800, but focused to the KPI and the properties that are very important in the context of ADS. Then we have horizontal activities. One of them is the IEEE P2851 that define many methodologies with which you can do those analyses. So it's a lot of things. If you are interested in some of those, you feel free to send me an email. I will be happy to describe those. But I mean, those are the standards that you have that you need to have in mind in order to get at Trustworthy AI. So then I am at the end of my talk. So I want to close with a video, but I really thank you for your attention, and I'm open to any questions.
Welcome, Daniel. I see a text from Hubert asking, can you pick me up from the San Jose Civic? Should I take you there?
Yes, please.
Okay, taking you to San Jose Civic.
Start Drive Pilot.
Okay, starting Drive Pilot.
Can you let Hubert know we're on our way?
Sure, I'll send him a text. I see Hubert.
Can you please take me to Rivermark Hotel?
Okay, taking you to Rivermark Hotel.
Thanks for picking me up. Definitely. Start Drive Pilot.
Okay, starting Drive Pilot.
What building is that there?
That building is San Jose Center for the Performing Arts.
What shows are playing there?
Cats is playing tonight.
Can you get me 2 tickets for Saturday night?
Yes, I can. You have arrived at your destination.
Please park the vehicle.
Okay, finding a parking spot.
Okay, so that's all from my side. I'm open to any questions.
Thank you very much, Ricardo. A pleasure as usual. And there are so many questions. Your standardization forest is really impressive. When are all these standards going to be available? A standard is only useful if it's early enough in the stream of development and can be really worked in. So who's faster? People to standardize or people who will write the applications?
Oh, that's a very, very, very good question. So I would say the first answer is that in 2023, so in between end of this year and end of next year, several of the standardization activities will be done. So one of the key things we do in standardization is, in fact, we need to be very careful. We cannot have in standards something too advanced like research things, because otherwise it's impossible to be sure that those kind of guidelines are good. So we need to have something that has been somehow already, I would say, used by the entities that are working in standardization activities. So somehow the standard, I would say, is a kind of a snapshot of the technology of the state of the art. This is the role of standard. In the case of AI, it's a bit in between, in the sense that if you look at, this is why a lot of those standardization activities are not yet a fully IS, so a standard with strong requirement, but are more guidelines. The reason is that a lot of the techniques, for example, for safety and security, are new. And so we want the industry to read and use those guidelines and then to prove it.
Obviously, it can only be a picture of the momentaneous status. Otherwise, you will be totally lost. Yes. Okay, so a very practical question by Duru Balan. Is there any public automotive cybersecurity framework available which can be used already for automotive security? Are you aware of anything that is signed off already?
Yeah, so there are few of those. For example, the technical report, the 4804, this is published. It includes the first version of the Annex B with something on ML. Also, there are, for example, the ISO 21448, I think is the FDIS is already available, and the FDIS also has an annex on ML. So there are few ones that are available also from the IEEE side. If the person is interested, I can send out a list.
Okay. So please go back directly to contact Ricardo. He will be pleased to answer you. Another question, PJ Capelli, he's asking, he's obviously living in a very snowy area. Is there any chance that AI applications are going to work in a snowy environment as well?
Oh, no, sure. I mean, I cannot mention names, but one of our customers, both for car and trucks, is in fact in a snowy region, for sure. One of the reasons of doing verification in simulation is also to do that. You may have seen in one of the video, we have generated scenario. We generate scenarios with different weather conditions, water, rain, and snow. But that's it. I mean, it's not just a game, a simulation game. This is really with hardware in the loop. So sensor, they receive those information and they need to react accordingly. So the short answer is yes. Those are in the play. Then, of course, the vehicle can react in different way. The MRM, so the minimum risk maneuver, they can be different. The autonomous vehicle may decide to do different things, but yes, the short answer is yes, those are considered.
Yeah, I have seen a video, for example, from the University of Tallinn, and obviously in Estonia, there's lots of snow as well, and they were really successful in driving one of these people movers through the campus of the university in Tallinn. So yes, it seems to work, yeah. Good. One more question, and then we have to finish our session. Yeah, people are coming back again and again to the testing issue. Emmy Heidner, if we use random scenarios for testing, how do we have a robust testing? Repeating tests cannot be done in any deterministic manner. So how do we ever have transparent test results? Very general question. No. Yeah, Ricardo, what is your view?
It's a good question. So the message is that, of course, randomization is not the only thing. The randomization is used in a context in which you have already a test plan, in which you have already identified a set of edge cases, and then you want to identify all the possible combination of those. So one of the things that I suggest you to read, I think in September, the DTR of the TR5469 will be there. And in there, we have a set of chapters exactly on testing and simulation. Of course, if you remember the slide with the pyramid, we don't say that, I mean, just simulation on one level is sufficient. You need to do everything. You need to do simulation at the component level, at the system level, and then at the road vehicle level. So the randomization is one aspect of it. We have, for example, a very detailed, either human-based or AI-based technique to label the scenarios and then to identify for each of the ODD that we define as a goal to define the set of tests. I will be glad to give more information if needed.
Okay, thank you very much, Ricardo. It was a pleasure. So thank you very much to Daniela, to Joan, and Ricardo for this enlightening presentations. The ladies in the background, we are going back now to the PowerPoints. I hope so. Okay, I hope it's back. So we are going to finish here now. But the system is working. Yeah. Okay. So the idea of our industry connection group is to discuss hot potatoes. And I learned today definitely to go for AI in automotive applications obviously is a hot potato. The amount of questions is surprisingly, we have more than 60 or 70 questions. And don't worry, nothing is going to be lost. We will pick up everything as far as possible for our webinar stroke workshop in October. It will be virtual as well as presence workshop. Okay, obviously depending situation on COVID, but I really hope that some of you are going to have the opportunity to see us live as well. It's going to be presumably in Munich. Final decisions are to be made soon. So whenever you have any idea, please come back to me, come back to any of the other guys. We are really living from your contribution. You can ask for any idea, any input, whatever you like. We will try to satisfy all needs of the community to identify live issues, problem issues, whatever what needs to be done. That is the last and final chart. I would love to point again to our October workshop. The title may change still, but for sure it's going to be about artificial intelligence for autonomous vehicles. The question is, of course, where do we stand? What is missing? And I'm learning again and again. The world might go faster than we believe. Yesterday at the AEK in Ludwigsburg, there are still a lot of questions, but there are a lot of solutions on the way as well. It will be an interesting discussion, I'm very sure. Thank you very much for your attendance wherever you are. Have a nice day, have a nice evening. Enjoy the rest of the day. Bye-bye. Thank you.
Bye-bye.
Bye.